Okay, guys, this is going to be Triangles and Circles Part 2. This is Unit 1, Lesson 13. Okay, so not only am I going to throw in some stuff from Lesson 12, just to kind of remind you to keep the refresher there, but we're also going to add some new things on. Okay, so your learning goals is to define and identify the points of intersection associated with triangles. Use a compass and straight edge or technology to construct points of intersection in triangles and circumcise and inscribe circles of triangles. Okay, so let's jump into this. The median. The median is a straight line that goes from a vertex to the midpoint of an opposite side. So let's get my highlighter. So here we have our vertex. So we put our pin there and then we draw a line down to the midpoint of the opposite side. Since that is a midpoint, it makes that side and that side equal to one another. The other thing that it does, so if you read the note down here at the bottom, okay, it makes this triangle equal to this triangle. So when you go from a midpoint or a vertex to the midpoint of the opposite side, you create two new equal triangles within that triangle. Okay, a centroid is the point at which all three medians intersect. So if you take each vertex, we have only three on each triangle, if you take each vertex and you draw their medians, this point right here at which they meet is called the centroid. Let me finish my tick marks here. Okay. And it says the centroid is the triangle's center of gravity. This is kind of like a fun fact for you. If you were to make a triangle out of some stiff material and locate the centroid, you could balance that triangle at that point. So that's pretty cool. You might want to try that sometime if you have some time on your hands. Okay, here's an example for you. It says label the missing parts of the figure. All right, well, I look at this first line that it's pointing to. We'll do that one in pink. Okay, it's coming from a vertex, it's going to the opposite side, and it's cutting it in half, so it's the midpoint. What is that called? That is called the median. Okay, then now let's look at the next one. Okay, it's pointing to this spot right here. Okay, that's in the middle. All those medians meet right there at that point. So that is called the centroid. Okay, moving on. Now we're going to put it in kind of like verbiage text. All right, so the blank is the line segment from a vertex to the opposite side's midpoint. Okay, well, we should know that. That's what we've been talking about. That is our median. The intersection of all of these medians is called the centroid. Okay, so now that you've learned these two new terms, let's go back to 112 and remind ourselves of some other things that we looked at. Okay, so this first line that it's pointing to, if you look at what it's doing right here, okay, it's taking that angle and cutting it into two equal parts. That is called an angle bisector. Okay, the point at which all of those angle bisectors meet is called the better pin. The end center. Okay, so angle bisector goes with end center. Median goes with centroid. I'll try to send a graphic organizer out for this, everybody to have. Okay, and then also from, I think it was 112, is label these missing parts. So let's start with what's given right here, this line right here. Okay, it cuts that line, the line that it's pulled up from, in half, and it forms a right angle. That is called a perpendicular bisector, because it bisects it in half, and then it also makes a right angle, perpendicular bisector. Okay, and then the point at which all of those meet, oh, whoops, that's supposed to go right here. I'm so sorry. Too bad we aren't in class. Y'all could correct me. That would be great. Perpendicular bisector is right there. Okay. Let's take that off of there. Okay, the point at which all of the perpendicular bisectors meet is called your circumcenter. I know that all of these words are just so super crazy. That's why hopefully I can get a graphic organizer going for you. The circumcenter. Okay, so let's wrap this up. The circumcenter, the incenter, and the centroid are all special centers of triangles, okay? They all kind of contain that word center. For any triangle, each of these points can be found using a compass and a straight edge. The construction of an incenter is based on the triangle's angle bisectors. The construction of the circumcenter is based on the triangle's perpendicular bisectors. And then the construction, I know it's not listed here, but the construction of the centroid is drawn from the medians of the triangle. All right, guys, so stay tuned. Hopefully I can get a graphic organizer out for you. We can really tie all these things together. Have a great day.